did your z-scores. We took a z-score, whether they were positive or negative, and we could look up the area to the right, to the left, whichever way we were going. We always find to the left. If we needed to the right, we'll subtract from 1, and we could figure out what your percentage is, what your probabilities are, and we worked on that. So say I gave you a z-score of 1.2, and that z-score was right here, 1.2, and I asked you for your area to the left. So how would you find your area to the left of a z-score of 1.2? Go to your chart. So you can go to your calculator, and when you look up this area, it is the area to the left. So you go to your chart, you look up 1.2, and you get 0.8849. Now, does it make sense? It's over 50%? Yes. It's over 50 plus 30. It's over 80%? Yes. If we wanted the area to the right, how would we find the area to the right? Subtract it from 1. 1 minus this. Or, good, we could look up the negative 1.2. That was another thing we did. Very good. We looked up the negative 1.2 because this is symmetric. And then we would find that. Now, we're going to put a little spin on this. Say, we know the area is 0.8849. We knew the probability of this happening was 88.49% that it would happen. We want to know what's that z-score that corresponds to that area. So you could do one of two things. You could go to the table and you could look it up in the big part of the table. You could look up 0.8849 and you'd find it, and you'd probably see a pattern. In the negatives, you're going from 0 to 50. In the positives, you're going from 50 to 100%. So you can look for the 80% something or other in the positive section. You could find it in your table, and you could bubble out the z-score, right? Or you have a very nice calculator step, and this is the one step I always use my calculator for. It's called inverse norm. Do the inverse of my normal curve. You would find it under second VAERS, number 3. Now, on the yellow calculators, the 84s, it's going to ask you for the area, 0.8849. It's going to ask you for the mean, 0, standard deviation, 1. We're on a standard normal curve. This will return you the z-score. You have to round that z-score to 2 decimals. Now your calculator is far more exact than even we find it in your table. So it's going to be like 1.198 something or other, or 9 something or other, whatever this says. You got to round it to the 1.2, 0, or 1.2. Now, on the 83s, you're just going to have to string this out. You're going to do area, mean, standard deviation, 0.8849, comma 0, comma 1. This is going to return you the z-score. And then you have to round your z-score to 2 decimal positions.
So what's the difference?
The difference is the calculator. If you have an 84, it'll prompt you through the steps. The 83s, you have to string this out. That's the only difference. You don't get the prompt on the 83. With the 84s, it prompts you. So we can find the associated z-score with that area. Okay, so let's try one. Now, for the time being, I want you to make a sketch. I want you to see which is less than 50%, which is more than 50%. Is my z-score positive? Is my z-score negative? Because you can use the concept of symmetry. You can always look up a negative one, but you have to place the positive one. So you're going to find a z-score that corresponds when they say cumulative area, they mean area to the left, because we read left to right, of 0.3632. Now, in my curve, would I find 36% of my curve below the zero or above the zero if I'm reading from the left to the right? To the left. Good. This is my 50% cutoff, isn't it? So 36% would be somewhere here. So do I expect my z-score to be positive or negative? Negative. So I do my inverse norm, and I look up 0.3632. Again, standard deviation, your mean is 0, your standard deviation is 1. We're on a standard normal curve, and you're going to round this to 2 decimals. So what would you come up with?
So you just type in 0.3632.
Yeah, and yours, but keep it at the 0 and 1.
Okay, so negative 0.34.
Negative 0.3499, so round this to 2 decimals. Good. So the z-score that corresponds to an area to the left of 0.3632 corresponds to your z-score of negative 0.35. Could you also take this table and locate 0.3632? Now, look at negative 0.35. It's exactly 3632. Sometimes you won't find the exact number in here, and you'll have to find the area that's closest to that z-score. If you looked it up in here. Let's say I'm looking, I know it's less than 50, I look in my negative section, I find in here between 0.362, the 0.3632, and I extrapolate my z-score. But sometimes you won't find the exact value. For instance, say I want the area to the left to be 0.4991. I want the z-score. Now, look in your table. I'm still in the negatives. I want to see if I find a 0.4991. Do you see a 0.4991? No. Okay, 0.4991. Do I see a z-score for 4991? Not exactly, right? I see a 0.4960, and I see a 0.5000. Which one is this closer to? 5000. So I'm going to have to go with this z-score. So my z-score is going to be about the 0. It's almost 50%, right? But I'm not going to see it exactly in my chart. But I'm going to have to go with my z-score of 0. Do you see what I'm saying? Why it's a little trickier to use this? But do inverse norm. Inverse norm, put in 0.4991 and round it to 2 decimals. And you get a z-score of 0. Yeah, I'm not worried about the final now. This will start coming to you. Like right now, we're going to be sketching and figuring it out, but this will come real easy to you. Because it does make sense. What happened is we had like 10 days that we haven't really visited a lot of the characteristics of your curve. So do you see what I'm saying versus looking it up in the table versus using your calculator? You can find it, but not exactly always. Okay, so let's try another one. There's another way they could write this. Find the z-score that has 10.75% of its distribution to the right. So I'm going to make this be a decimal. And I need that area to be to the right of this z-score. So Richard, would I have a positive z-score or a negative z-score? Positive. Are you positive? Yes. So in my positive z-score, this area has to be less than 50%, doesn't it? And this is this area right here. But when I look up my z-score, don't I always look up the area to the left? So one of two things we can do here. We can do this as 1 minus this and look that up. Or what's another way we could do this? Look it up and then make it negative, right? If we look up this, if you did this, inverse norm, and by the way, inverse norm, watch how nice this is. You can just leave it like this. You don't have to subtract it yourself. You can let the calculator subtract it. And your mean and your standard deviation. Or I can do inverse norm. I can look up this guy, and this will become a negative, and all I have to do is turn that into a positive, because I know my curve is symmetric. So digest this with me for a minute. Put this in your calculator. Even with the black calculators, you can do it like this. Watch. Put an extra set of parentheses here. Parentheses, comma 0, comma 1. Even with the 83s, it'll work if you string it out. The 84s are much nicer because you don't need the extra commas or anything else. So tell me what you get when you put this in with the 1 minus. So 2399 to 1.24. Okay? So tell me what you get when you put it in this one. Ricky, where's your calculator? Well, go get one. So how are you doing this without? How are you guys doing this without? You're looking it up on your table?
Yeah.
Good. So what would this one be? Negative 1.24. So now that I have my sketch, is it possible that this could be a negative? No. So I know, because I have symmetry, that this is a positive 1.24. You gave it to me. You gave me negative 1.24. Where's my calculator? You gave me that answer.
No, I understand how you get the positive.
Well, your concept of your properties, your concept is your curve is symmetric.
Are we ever going to have to do a non-symmetric curve?
No, only with the normal curves. Because in your calculator, you have to put a separate set of parentheses here. You have to do this, put a separate set of parentheses here. Then do your 0 and your 1. Don't ask me about binomials if we're doing this. Okay, now, where am I going to find the z-score? In the positives or the negatives? I want the area to be 96% to the right. Negatives. I want this area to be 96 points. So, I have two choices. I can look up the inverse norm 1 minus this. Okay, and what'd you get? So Richard, you looked it up. What'd you get?
Negative 1.877.
7. Good. 1.77. Or I can flip this and look up inverse norm and find this area to the left of this. But then I have to remember that I want the negative. I have to remember I want the negative because this is where I want it to be. Okay. So